it's Matt from Eastwood Company and welcome to another Eastwood Tech video. Today we're going to cover the basics to MIG welding. I want to show you guys that are just starting out some of the things you can do that are going to jumpstart you to making some really nice welds. So let's jump right in. So the basics to MIG welding, we're going to show you what the machine looks like, what it does. As far as Eastwood machines go, we have a number of different machines. The one we're using today that we're going to focus on is the Eastwood Mig 175. This machine here uses 220 and is a 175 amp machine. Over here we have Eastwood Mig 250. This unit is a 110 and a 220 unit, and also is obviously is a much higher rated unit. And then for you guys that want to use just 110 voltage, you can use the MIG 135. This is again 110 only. It's great for light sheet metal work up to medium fabrication. So that's what we have available, but we're going to show you the MIG 175 today. So the MIG welder is using, the basics to the MIG welder are a couple key elements. This item right here, this is the torch for the MIG welder. It's pretty simple. You press a button, wire comes out, start making a weld. So there's a little more to that happens inside the machine, but that's the basics. So the MIG torch here, we can go down onto the table and you can see what's made up, the parts that are inside of the MIG torch. So this part right here is just your nozzle. You have these like this. So this is your nozzle here that just kind of directs your shielding gas onto the workpiece. This contact tip right here is where the wire actually comes through. Now these you do need to size to the wire that you have inside the machine. There's all different types of wire that you can use for general fabrication and automotive work. Anything from 023, 030, or 035 are the most common ones. So you're going to want to make sure that you match your contact tip here to the size wire that you're using. The last part here threads into the torch last. This has little holes that you may be able to see drilled into the outside of it. That's where your gas actually comes out of the MIG gun, and that's directed through the nozzle here and is directed over the workpiece. What this does is it keeps the area that you're welding pure. It gives it as it's called, shielding gas. It shields the weld to keep any impurities that are floating in the air out of your weld and gives you a nice clean weld. So that's the makeup of these. Generally these parts do not need to be replaced very often, but occasionally you will get an instance where you'll burn your wire to the tip of this, or occasionally this gets built up and just gets worn out from abuse. But generally they last for a really long time, and you don't have to buy these every time you buy a spool of wire or anything like that. So that's the MIG torch. The other part is the ground clamp. When you're welding, you're basically short-circuiting. You're creating or completing the circuit when you weld down into the piece. So this ground clamp here, you can either clamp directly onto your workpiece, onto what you're welding, or in an instance like this, we have a nice clean work table. I like to have a nice clean metal welding bench so that I can clamp somewhere out of the way so I'm not running into the the ground clamp. I'm not knocking it off with my hands or anything like that. So I keep it off to the side. Now if you're working on a car, or if you're working on a table that's maybe pretty dirty, you want to definitely clamp as close as you can to the area you're welding. So if you're welding on a car, you may need to sand off an area that's maybe 12 inches away, or a little more away from where you're welding, so you get a good connection and a good clean weld. You will notice that your weld quality will suffer if you put this ground clamp too far away. So again, we have a nice clean table here, so I'm going to clamp it off out of the way so that I'm not knocking it off. The other important part to the welder is that's a little different. There's flux core welding and there's MIG welding. The difference between the two of them, they're very similar processes in which the wire comes out of the MIG gun and then you actually create the weld. With flux core, you do not use gas. So you're actually using a type of wire that has a flux around it that when it burns, it creates your shielding gas. So it does not use a shielding gas. And you can make a strong weld this way, but for automotive use, like most of what we're doing, it isn't as clean of a weld, and it creates a lot more spatter and it may be a little more difficult to do sheet metal work because the size of the wire is a little larger. So we generally, for most cases, stray away from that when doing automotive work. So today we're going to show you actual MIG welding, which there is a gas that's used, and I'm going to walk around here and show you the bottle of gas we have. So for most ferrous metals, you're going to be using a mixed gas here. And the gas, as you can see, if you guys are ever curious or unsure, all the labels when you get them from the gas supply store, they're going to have a makeup on it here. So what we like to use for general fabrication is a makeup of 75% argon and a 25% CO2. So that's pretty good for most general use. You can start playing with different mixtures, but that's gets a little higher end than what we're going to cover in this video. But 75-25 is a safe mixture to use. Now, the other important part that we're going to show you here is if you have gauges similar to this, like would come with the Eastwood machines and are used with a lot of different machines, it can be a little tricky and something that we notice that beginners mix up and can cause a little bit of trouble. So first, this gauge here. This is just showing what's inside the tank. So you're just monitoring how much gas you have left in the tank. That's pretty self-explanatory. The important one is this one over here. So we'll open this bottle, make sure it's all open. You might notice that there's two sets of numbers here. And these numbers, it has a pounds per minute and has a CFH on here. So the difference between these is these numbers are almost, the pounds per minute is almost double what the CFH is. So generally, I want a flow of 12 to 15 is what I like to run at CFH. So where you can make the mistake is if you just reading in the instructions, you hear somebody say you want 12 to 15 flow. We've seen people adjust it by this outside number. So if you're at 15 to 20, or if you're setting it at about 20, so do you get 15 when you're hitting the trigger, you're all the way up here. You can see where the needle is where we want to be. So make sure you're double checking that and you're reading off the inside numbers. If you're reading it out of the instruction manual, make sure you're keeping track of your gas. A surefire way to tell if you have this incorrect, it'll sound like you have an air hose leak when you're welding. It'll be really, really loud, the shielding gas that's coming out of there. If you hear that, you may want to come back and double check and make sure that this gauge isn't off. Somehow your knob here didn't get bumped. But this knob right here, you just turn the knob to adjust the flow and hit the trigger on your MIG gun. That'll purge out some gas and it'll kind of get your needle in the happy spot. Once you got that where you want it to be, then you're ready to weld. So that's the shielding gas, the basics to the shielding gas. So as far as the controls on the front of the machine go, the MiG 175 and all the Eastwood MIG welders are pretty simple. There's not too much to confuse you here. You of course have your on-off switch, just powering the machine on-off. We have an over temp. This is only if the machine hits its duty cycle or if something happens with the machine. But generally you're not going to see that. The two important parts you're going to see here is the arc volts and the wire speed. So your arc volts, the simple way to describe that is that's how much heat's coming out. That's the heat that it's creating. Obviously, upping the arc volts, you're going to get more heat out of the torch. And the wire speed is just as it sounds. It's how quickly the wire's coming out of the MIG torch. What you want to do is blend the two of these together to create a nice frying bacon sound is the way that a lot of people describe it. That's the sound that you want to hear when you're welding. The Eastwood MiG 175 and all of our Eastwood MIG welders, we have infinite adjustability on our machines. So these knobs, they can be twisted. There's some of the machines you'll see out there, they have just settings that you can't go like a half setting. With our machine, you can go in between any of these settings halfway to really dial in the machine how you want. So there may be times where you need a half setting, 4.5, and an I and a half. You may need something like that. So that's a really great feature. You can dial it in, but again, you got to make sure you know what these knobs do so you can really blend them together to get a really nice weld. So that's the basics to the front of the machine. The controls. So the next thing we're going to cover before we get into actual welding is just the basic safety of MIG welding. MIG welding and any welding puts off UV rays that are very, very bright. It's harmful to your eyes. It's harmful to your skin. Just like when you can get a sunburn, you can get a sunburn or a welder burn from welding without with your skin exposed when you're close to the weld. So you definitely want to wear some kind of long sleeves, if preferable, a welding jacket. The one I have here is obviously an Eastwood work jacket that we have that works pretty well. It's going to save your skin from any sparks that are flying. It also keeps you protected from the the bright light that's coming off when you weld. The next thing that you want to do is you want to protect your hands, both from the sparks and the heat, as well as from the bright light that's coming off of the weld. So I like to just use these are Tillman gloves that we offer in a couple different sizes. These are generally like a medium thickness glove for use for MIG welding. There is heavier duty gloves that you can use that are generally more used for stick welding or higher amperage welding. They are definitely great and keeps the heat off, but if you're doing something where you need a little more maneuverability, they're not always the best bet. So these I've found are probably the best all around for doing automotive work. So you'll be seeing us wearing these. And notice they have the leather cuff here. This is going to go up above my wrist to protect this top part of my arm to keep it again from getting burnt from the heat as well as the bright light that's coming off. The other thing that we have here I'm going to show you is you want a welding helmet. So this one here is a newer welding helmet that we recently came out with. It's a really extra large view helmet. This helmet is a auto dim helmet. What that means is that this helmet actually has sensors in here that sense the extreme bright light from welding, and it will automatically dim the lens down to whatever the setting you have on the side of the helmet here. So these settings, they basically set the lens darkness. So if you've ever used a fixed helmet, which has a fixed lens, like an 8 or a 10 or a 13, this kind of can do it all. So this particular helmet will go all the way from 5 to 13. So it's pretty good. You can go down to a real low lens darkness for if you're doing brazing or something like that, not related to MIG welding, all the way up to a 13 if you're doing some higher amperage welding where you need that extra protection. So this is going to protect your eyes. This is going to darken it so that you can actually see the weld that's going on. If you try to weld without this helmet on, you're going to see nothing but a bright light, and you're actually going to burn your eyes. You're going to get what's called welder's flash. You're going to wake up in the morning. It's going to feel like you have sand in your eyes. It's horrible. I don't wish it upon anybody, but it's going to potentially happen to everyone when you're welding. So wearing a good helmet, an auto dim, is a great reason to wear one of these, is so that you don't have to flip the helmet down or forget it, possibly accidentally get welder's flash. So we'll be using an auto dim helmet today. It's a great investment. We have everything from a real cheap one that has a smaller lens up to the higher end one that has a larger lens, a wider range of lens, the darkness of the lens, as well as it has a grind feature on it, so that if you're just grinding, you don't have to flip your helmet up. You can flip it to grind, and it won't actually darken the helmet from the sparks that are coming from it. So that's your helmet. That's just the basic safety. The kind of no-brainer stuff, welding creates heat. It gets really freaking hot. So be careful when you're welding. Don't put your arm on it. Keep your arms away from it. Even after you're welding, make sure you're keeping away from it, and keeping your torch and everything away, because you don't want to melt part of your machine or your whip here from the heat from that. So pretty simple stuff, but it's definitely necessary to mention to make sure that you're not that you're keeping yourself as safe as possible when doing this. So now that we have that done, I'm going to show you guys basically how to hold your hands, some technique stuff, and then we'll jump into actual welding and diagnosing your weld. So we'll save this here for in a minute or two. So when you're welding, a big mistake that I see beginners make is that they try and just hold their torch with one hand. So they just try to hold it, and they try and weld along with one hand. What happens is, you know, you're fighting gravity at all times. It's trying to pull you down. So when you're trying to weld with one hand, you're going to tend to kind of go up and down because your hand's going to want to go down. You're kind of fighting it with your muscles. What happens is you're changing the distance between the torch, the wire, and the workpiece, and it's going to create an inconsistent weld. What I like to do, and is a big thing that seems to help with beginners, is take that extra couple minutes, or a couple seconds rather, to get yourself comfortable. You know, put your wrist down, put your arm down. And what I like to do is I either use the edge of my hand, so I'll actually put on a set of gloves here so you can kind of see what it looks like when we're live. So you got your gloves on. So what I like to do is I put my arm down, and if we're welding in this area here, I like to try and put my torch, this little curved part, I put it over my hand, either over my first finger here. And what I like, the reason I like doing that is it gives me some maneuverability. You know, I can kind of move the torch around wherever I need as I'm welding. So when you're welding, and we're going to show you in a few minutes, you're going to actually move your torch around in circles or letter C's to kind of move the puddle and overlap it how you want. So by doing this, you're already kind of in the sweet spot, and you can just drag your hand or your arm like this. I've seen guys that use their wrist to do the same thing. A million ways to skin a cat, doesn't matter. You can hold your hand however you want. But I do suggest trying to get yourself as comfortable as possible, get yourself nice and a steady place to rest your torch on, and always practice before you go. So if you know that you're going to be welding a section here, you know, make sure you can do a dry run. You know, make sure you can slide your hand across. You have a clean work area. If you're actually welding on a car or on something that's, you know, out in the field, and make sure you're comfortable. If you need to set something up that you can rest your arm on so you can make a nice pass, do that. You know, make sure you're definitely comfortable, because the more comfortable you are, the better your weld's going to be. You want everything you can do to make your weld better. You know, every little step you can take is going to help in the end. So that's how you hold your hands. I like to keep I would say, anywhere from a 10 to 15 degree sweeping your torch back. So I'm left-handed, so in this case we're going to be pushing the weld. So what I mean by pushing is we're pushing forward. We're not dragging back. So we're going to be pushing forward, so I like to travel from left to right. So I'm going to be left-handed, so I'm kind of moving this direction. If you were right-handed, you know, we'd be doing the opposite. So we'd be starting here on the right, and we'd be moving to the right and going over like that. We could talk for a little while about push or pull. There's a lot of different opinions. For general fabrication and, you know, for you guys learning, pushing is probably the best thing that you want to learn. There may be instances where you may need to pull. If you're doing out-of-position welding or overhead, you may have to change the way or the direction that you're welding. So today we're just going to show you how to push, to learn the basics to how to lay a nice puddle down. So 10 to 15 degrees down, or back away from the way you're traveling, and then you move across your workpiece. So that's pretty simple. You know, when you pull the trigger, it's going to create an arc. You want to have this tip here, and we'll show you once we start the machine up how to set the stick out, a quick way to do that. You want to have it just about touching when you start. You want to set it, you know, almost touching, just above, you know, touching the workpiece. So that way when you're welding, you're keeping that nice depth, or distance, sorry, not depth, away from the piece. What will happen, you do not want to be up like this. Big mistake I see people do is they hold their hands too high, hold their torch too high away from the piece. What that's doing is the stick out is way too far out of the torch. You're going to lose some voltage when you're doing that. So the actual heat that's put into the piece is going to be less than what you may think is in the machine, coming out of the machine. And number two, you're going to lose your shielding gas. You hold this too far away, the shielding gas is just going to dissipate into the atmosphere. So you want to keep this pretty darn close to the workpiece as you're traveling. So that's some common things. And we're going to show you once I start the machine up what it sounds like, what it looks like when you hold your hands too far away. It'll be pretty obvious that it's not a good thing. So that's the basics to holding your hands. Now what we're going to do is I'll start the welder up. I'm going to show you guys how to diagnose bad welds. I think, personally, this is probably the most important thing that you can learn as a beginner. Even if you're not fully understanding what everything does, if you know the cause and effect and how to correct it when you're doing a weld, that will jumpstart you and make you miles ahead of other people just by learning these things. So I'm going to show you some quick and easy ways to diagnose your weld and how to correct them, and listen what they sound like. So we're going to start the machine up. I'm going to talk over the fan a little bit here. So we got our welder started up. Now, one thing I want to show you guys is setting the amount of stick out of your torch. So I have a little bit that came out here. What I like to do is these MIG pliers are extremely handy. They have a little cutter on the inside of the jaws that you can cut the wire off. They have some little areas with some knurled portions so that you can pull on the wire. You can also loosen the parts of the torch, like I was showing you, to take the torch apart. It's kind of a all-in-one tool, really handy. I definitely suggest getting at least one of these, if not a couple of them, to throw one on your workbench, one on your cart, so they're always in arm's reach. To set your stick out, a quick and easy way to get you set up is to take this, your cutters here, and you can either turn them to one side, like so, and you hold it against the actual nozzle like that, and you cut off your piece. So you're actually using the thickness of the pliers to set your stick out. So that's a quick, easy way to do it. If you're ever unsure, you can just flip this over and cut it off like I just showed you. Now, a good thing to do, especially if you're doing sheet metal welding, every time you weld, that last bit of weld that you do, there's going to be a little balled up piece of wire on the end of this. You can just start welding and weld it off as you go, but when you're doing some thinner gauge stuff, it takes more resistance. It takes more, because the wire's thicker, it's going to take a little more amperage to actually burn that wire, and it can kind of make your first little bit of weld a little funny or a little proud, a little tall off of the piece. So it's a good practice, if you can, to clip it off every time before you start welding, especially if you have the pliers sitting right there. It doesn't hurt to just do it. So put my helmet on here. What you're going to want to do, and I showed you guys briefly in the beginning, what we have here, I just drew it quickly before we started. You're going to want to move your hands in like a letter C pattern, or you can kind of do circles. So this piece of paper I showed here, this is the letter C. So I'll show you guys both ways what it looks like. That's kind of what you're doing across the workpiece. You're doing little loops or little C's. What that's doing is you're kind of stepping back into the weld, the previous weld. Make sure that you're stitching everything together and you're not getting any holes in the weld. So this is my smoothest drawing I'm going to show you also here. That's basically the idea of what you're doing. You'll let us C's out of the shape. So you'll see when we're welding. Go to the camera guy here. He's going to flip down a lens. We got a little welding lens on the end of the camera. You're going to see it's probably going to go dark for a split second, and then we'll start welding. So you should be able to see my hands, or the end of the torch rather, moving, and see the weld as it's occurring. And you can see what I'm talking about with the different movements. So I'm going to start off by letting you guys hear what it should sound like. And then we'll go into the different incorrect settings. So get up close here. I'm going to start somewhere right in here. So I'll get my hands set. And the nice thing about these auto-gun helmets is I can put my helmet down before we even start.